Hi, everyone. Welcome to the final day of the USACO Bronze class. And yeah, we'll begin now since it's already 1:03. Okay. So this last class is about greedy algorithms. So a greedy algorithm it doesn't refer to just one algorithm. It refers to a class of algorithms which make the best looking decision at each step. So, for example, if you're a hungry person and you're greedy, what you would do is you would try to take at most food as well at once because your goal is to eat the most food, right? Because you're hungry and greedy. So at each step, you would take the most food to satisfy your goal. So that's just, yeah, that's what a greedy algorithm is. All right, now we'll go to one specific type of greedy algorithm, and I'll display it using a problem. And it's a pretty common problem. It's called the coin problem. So what happens is you're given a certain currency of coins. So we'll use like the American currency as an example. If we have 1 cent, 5 cent, and 10 cent coins, we want to create a given target sum using the minimum amount of coins. So as an example, let's say we tried to create 18 cents. What we would do using a greedy strategy, we want to get the most cents possible, right? And we want to get the closest to our goal. So the closest coin to our goal right now is 10 cents because it's not over our goal. It's not more than 18 cents, but it's also more than the rest. So we're going to take that 1 10-cent coin. Okay, after that, we already have 10 cents. The next step to get closest to our goal, we would take a 5 cent coin because that's the next one that doesn't go over our goal, but it's also the greatest one. And then after that, we can't take any more 10 cent or 5 cent coins. So we're going to take three 1 cent coins. And that gives us 5 total coins, which we're using to make our 18 cents. And that's the greedy solution for this currency. And it turns out you can do this. There's just a greedy solution for this type of currency, but it doesn't exist for all types of currencies. So let's take a look at this new currency. Let's say that we had instead a 1 cent, 3 cent, and 4 cent coin. So if you tried to create 10 cents using a greedy strategy, what you would have is you would use two 4 cent coins because those are the biggest so far and you're not going over. Then you would take two 1 cent coins. So in total, you're using two 4 cent and two 1 cent coins. So you have 4 coins in total. But the problem with this is that you can do this in a better way. What you can do is you can take one 4 cent coin and two 3 cent coins. And that still adds up to 10 cents, but it only uses three coins. So, but that's not greedy, right? Because after we took that first 4 cent coin, we still could have taken 4 cent coin, but not gone over our goal. But we didn't do that. We took two 3 cent coins instead, and that got us to our goal faster using only three coins. So this is just to display that a greedy approach it does not work for everything. And specifically in this case, to solve this type of problem, you need to use like a gold strategy. But we're talking about a bronze strategy right here, so greedy. And uh, we'll try to wrap our heads around this. And in order to do that, we're going to use an example problem, which we'll see in the next slide. So the importance of this, as I said, while these don't always work, they make it a lot easier to solve problems when brute force doesn't work. Like in last class, we saw the problem sleeping in class. If we try to brute force that problem, we would end up with 10 to the 10th operations, which we can't use. So instead, we used another strategy where we combined two classes together, and that was kind of also a greedy strategy. And at the bronze level, there's not like completely greedy problems. That happens more at the silver level, but a greedy approach can often help. So here's an example problem. It's called Mad Scientist. And I'll leave a link to this in the chat so you guys can access that. Oops. So can you guys see my screen now? Okay, good. So I left the link to Mad Scientist in the chat. Let's just read the problem first of all. Okay, so what happens is Farmer John has ordered a bunch of cows, and he's ordered N cows specifically, where N is up to 1,000. And each of those cows can be one of two breeds, Holsteins or Guernseys. so H or G. And what happens is Farmer John actually ordered them in a specific order. So we're gonna get a string A, which tells us either like there's gonna be n cows, and each character of the string represents whether each cow is an H or a G. So he wants to get his exact order that he got, right? The exact order that he ordered. But instead, what he received was another order of cows B, which is another string of length n. And all the cows in B are also H's or G's, but they might not exactly match what he wanted in A. So in order to fix this, he's going to use a machine where he can flip any substring of cows. So he can take any consecutive set of cows in the string that he has, and he can flip all the cows in that string. And if it's a G, it'll become an H, and if it was an H, it'll become a G. Okay, and he wants to use this machine the minimum number of times possible so that he can turn the string he got into the string he wanted to get. So we want to find out what is the minimum number of times we need to use this machine in order to turn what he got into what he wanted. So if we try to just flip everything possible, if we try to brute force this problem, we're going to have a lot of strings to flip, right? We can first choose every possible substring, which will take n squared time, because you have n time to choose the starting point, you have n time to choose the ending point, and then if you multiply those together, you get an n squared algorithm. And not to mention, that's not it. You also have to check which order, because you're not only flipping them once, you can also flip them multiple times. So if you did that multiple times and we tried all the possibilities and all the order, it's going to take a long, long time to figure out our answer just by brute force. So brute force will definitely not work here. So instead, we're going to have to use a greedy approach. And to think about a greedy approach for this, let's first think about what happens when we flip. So let's say I'm going to take my sample case. I'll just copy paste the entire thing. So I have my sample case right here. All right. So I see that the second string is what I got, right? And the first string is what I wanted. Although the one that I flipped doesn't really matter, because turning the one that I got into the one I wanted takes the same number of operations and the exact same operations as turning the one that I wanted into the one that I got. Okay. And also one thing that doesn't matter is the how, like, what order you do the operations in. Because whenever you do an operation on a cow, you flip it. And flipping it like in one order or another, it doesn't matter. You're still flipping it. It doesn't change the nature of the operation. So we can do our operations in any order we want. Okay. But one thing that's for certain is that each cow that is mismatched, so like if it's a G in the first string and if it's an H in the second string, we're definitely going to have to flip this position, right? And if it's already the same, like if it's an H in the original string and an H in the string we got, then we don't have to flip that. And if we did flip that, then we're going to have to spend another operation flipping or correcting our mistake. So unflipping the one that was flipped. So we're not going to waste our time in flipping strings that don't need to be flipped, right? We want to be greedy. We want to get to our answer directly. So what we're going to do is we're going to spend time only flipping the ones that are mismatched. So in this first one, you have a G right here and an H right here. So you definitely need to flip this. Let's count that in our operation. Okay, then, do we want to flip the second one? So there's another thing right here. In one operation, you don't have to just flip one cow at a time. You can select an entire range. So why not, don't waste that one operation on just flipping one. We can just go as far as we need to while still flipping cows that are mismatched. So if this cow, like this second position cow right here, if that was also mismatched, we could flip that one in the same operation that we flipped the first cow, and that would not waste an operation. So those are the two important observations for this, and I have them in this slide right here. So yeah, if we're trying to flip some cows, we should only flip cows that are mismatched, and also we should not waste operations in reflipping cows. So we also want to find the longest range of cows that are mismatched, because we can just flip all of those at once in one flip. So let's simulate that right here, or I'm going to go through this sample case right here. So this first one, we're going to flip, and I'll keep track of my answer down here. So our answer so far is 1, because we're going to have to flip the first cow, at least. So our answer is 1 so far. We're going to have to flip this first cow. Then we're going to move on. So the second cow is already fine, right? So we don't have to worry about that. Then look at this third cow. This third cow is mismatched, so we do need to flip that one. So our answer is now 2. And then this fourth cow, it's also mismatched, but we can flip it in the same operation that we used to flip the third cow. So we're not going to add 1 to our answer. So our answer for the entire string is just going to be 2, because all of these are already matched. So there we go. Now we have a working solution. We're just going to flip any range that is not matched correctly, and we're going to go as far as we can to flip the cows. So let's write that down in code here, or let's code that up. Okay, so I had a question saying, what do you mean by greedy approach? What I mean by greedy is that you want to get to your answer at once. You don't want to backtrack or anything. Like I used the example of the hungry person before, and you want to get closest to the answer too. So I use the example of the hungry person, where if you're hungry, your goal is to get the most food as possible, right? And you want to satiate your hunger as fast as possible. So what you're going to do is you're going to take the most amount of food at once, or you're at like a greedy hungry person would take the most amount of food that they can get at once to satiate their hunger. That's what a greedy approach is. You want to go as far as you can while not going over in order to reach your goal. That was also shown by the coin problem. Like we took the greatest value of a coin that we could without going over. And then that got us to our goal. But remember, greedy solutions don't always work. So yeah, so now let's implement Mad Scientist. Are there any more questions actually? You can also leave questions in the Q&A. That would be easier to answer than the chat. Okay, the first thing we're going to do for this problem is make our scanner as usual. And make our print writer. Okay. And then the next thing we're going to do is read in our input. So the first thing we have to read in is n, the number of cows that we have. Okay, after that, we have 2 strings. We have strings that are just consistent of G's and H, but we want to look at each character in order. So what we're going to do is we're going to use this string method called toCharArray. So what that's going to do is convert the string that we get into a char array immediately. So the type that we're going to store it in is a char array. So I'll call it original. And that's going to be equal to our input. And remember, to get the next string of input with the scanner, you do in.next. And then this thing right here is already a string. So what I can do is I can call the toCharArray method on it. And what that'll do will turn the string into a character array. I'm going to do the same thing for the new cows, or the received cows. All right. So now that we have that, we're going to go ahead and do our greedy approach. So we'll start our answer off at 0. So here's another defining factor of a greedy algorithm. So in other problems, what we did, in brute force especially, what we did was we tested out a lot of possibilities, and then we updated our answer to get the best one at each step. But when using a greedy algorithm, we're not going to do that. We're just going to build to our answer all at once. So that's one key factor that's different between greedies and brute force. We're building immediately to our answer. So in order to do that, we're going to scan from left to right through our string. And at each point, if we have a mismatched cow, so in order to test for that, we're going to say if original at x is not equal to received at x. So if those 2 cows are mismatched, then we're going to want to increase our answer. But we're also going to go as far as we can while doing this. So in order to go as far as we can, we're going to use the while loop because that'll allow us to go as far as we can while checking for a condition. So first of all, I do want to update my answer, but also while original of x is not equal to received of x, we're going to keep going. So x plus plus. This continues going in our array. Okay, another thing is that we don't want to go out of bounds. So we're going to check right here if x is less than n. Because if x is greater than n, then we're already at the end of the array, and reading in an index that's out of bound right here will cause a runtime error. So we don't want that. Okay, so now that we've done that, we're gonna keep going. And also this, after this while loop executes, we're either gonna be at the end of the array or we're going to be at an index where the two cows are already matched. So we don't care about that index. So it doesn't matter that we're already moving on from that. So that's why we don't backtrack for a second here, because it leads us to a position that we haven't checked yet. So it's fine either way. We don't need that one. And then we can just print out our answer. Because this is a greedy strategy, it'll just build up your answer. And now let's test this. So it prints out 2. That's the answer. Okay, so that was the first example of a greedy algorithm where we just where we used something about the situation to just build up to our answer. So here's another problem that we have. It's called even more odd photos. Oh, first of all, does anyone have any questions about this? I don't see any in the chat or in the Q&A. Okay, I guess you guys are fine with that then. So here's the second problem we're going to be doing. It's called even more odd photos. And I'll leave a link to this in the chat as well. Okay. So here's the problem. What happens is Farmer John is trying to take a photograph of his N cows, and each cow has a certain ID, which is a number in the range from 1 to 100. And what he wants to do is he wants to partition the cows into disjoint groups. So basically, he wants to partition them into groups such that each cow is in exactly one group. Then he wants to line up the groups so that in each group, the sum of the cows alternate in parity. So the first group has the sum of the IDs even, the second group has some of the IDs odd, third one even, fourth one odd, and so on. So we want to find what is the maximum possible number of cows or groups that Farmer John can form. All right. So in this problem, we're also going to use a greedy algorithm, and let me explain how. The first thing that we can observe here is that we only care about whether the IDs are even or odd, right? And some of the IDs are even or odd. We don't exactly care about what they are, right? So what we can do is when reading them in, we can just convert them to ones and zeros because we only care about whether they're even or not. And ones and zeros will represent one if it's odd and 0 if it's even. So now that's cleared. So we basically just have an array that we're getting of ones and zeros, and we want to put them into groups of evens and odds. Now let's take this one step at a time, and let's divide this into 2 cases. What happens if we had more even cows than odd cows, or more odd cows than even cows? Let's draw this out first. So if this was my array, and the first thing I can do is convert all these to zeros and ones. So in this first case, all the numbers are odd. So we're just going to have a bunch of ones. So that's what we basically have. Okay, so the next thing we have is that we have a lot more odds than evens, right? Because all of our numbers are ones. We have 0 evens. So in order to create an even group using odds, we're going to have to pair up 2 ones to create an even. And we don't want to pair up more, right? Because since we're trying to maximize the number of groups, we want to use the minimum amount of cows in each group. because if we used more cows in each group, we're going to have less cows to make more groups with. So that's the other thing here, that we only want to use the minimum amount of cows that we can use per group. So in the first group, let's see, we want to have it even, right? We want to have an even sum. So we're just going to have 2 ones in the first group. I'll call them O's. This is the first group, O and O. And I'll use the first 2 cows for it. So these 2 cows go in the first group. Then in the second group, we want an odd number, so the odd sum. So we can just use 1, 1 odd. Okay, and then in the third group, we've already used the first 3 cows, and now we want to make another even group. So we can use the next 2 cows. All right, so now we just have 2 cows left, and we have to make an odd group. So to do that, we can just make we can put 1 cow in that odd group, and that'll make an odd group. But here's the problem now. Since we already have even, odd, the next group has to be an even group. It has to sum to an even number. But the last number that we have is odd. So if we put the odd cow in that last group, we're going to have another odd group, which is not allowed. So we're going to have to combine this odd cow with some other group. The thing is, if you combine an odd number with any other group, it's going to change the parity, but we want to keep the parity the same. So this is not going to work. We're going to have to add our odd cow to some other group. Let's say we add it to the last group. Then this last group becomes even. So we can't have this, right? Because if we have another group, it must be odd. So instead, what we can do is we can combine this even group with some of the other groups. Let's say we combine it with this group right here, this other even group. Since this last group was odd, since this last group now is even, since it has 2 odds, once we combine it with this last even group, it won't have any effect on its parity. So that'll still be fine. So now we have an even group, an odd group, and an even group. And we just saw that no matter how we tried, we can't fit another group in here because we had that extra odd guy. And once we add him, all the parities will change. So this is the best we can do in this case. And the answer is the number of groups we have right now, which is 3. So that's the logic behind the first example. Okay, now let's think about the second example. So this was the input. In this case, we actually have an even guy, but we only have 1. So let's convert all these to 1s and 0s. So we have a 1 right here, a 0 right here, a 1 right here, 1 right here, 1, 1, and 1. Okay. So I saw someone in the chat said the second and third. So what's your question here specifically? I'm assuming it had to do with the last example. So let me get back to it. So could you elaborate on your question here? What do you mean by the second and third groups? Or did I already answer your question? Okay, so I think I guess I already answered your question. But yeah, if you have any more questions, you can just leave them in the chat or the Q&A and I'll answer them. But anyways, for now, let's just move on to our second example, which was this one right here. And let me put this back up. So here was our input. And now let me convert them all to 1s and 0s. This is a 0, this is a 1, this is 1, this is 1, and this is also 1. So we only have 1 even number here. Okay. So in this case, we still have more odds than evens. We have 6 odd numbers and we have 1 even numbers. So what can we do at first? So in order to create an even group, we want to use the least amount of cows, right? So we can just put that even cow in there and it'll create an even group and we're done. All right, so then in the second group, we want to create an odd number. So we can just put 1 odd cow in there and we're done. Now the third group, we want to make an even number. So we put 2 cows in there and then we're done. In the fourth group, we want to make it odd, so we put 1, and we're done. And now in the fifth group, we've already used 1, 2, 3, 4, 5. We have 2 left, and we want to make an even group, so we can do that with 2 cows. And now we've made all the groups we can. We used up all the cows, and we're done. So our answer should be 5. That's exactly what it is here. So these were all cases where we had more odd cows than even cows. But what if we have more even cows than odd cows? So the thing we have to consider here is that whenever we have an even cow and we have to add that to some group, that adding that even cow won't change the parity of the group. So we can add even cows anywhere we'd like, and they won't affect the parity. So the only thing we have to really worry about is where we place or how many odd cows we have. And for each odd cow that we have, we can place it by itself in one group, and that'll create an odd group. So the number of odd groups we have is just the number of odd cows. And then we have look at the pattern here. We have an even group and then we have an odd group, right? And that makes up 2 groups in a row. So if we group these up, we can make 2 times the number of odd cow groups and then plus 1 if we have extra even cows, because the next cow in the pattern would be even, but we don't have any more cows to make an odd group. So then we're done. So the answer, if we have more even cows than odd cows, would be 2 times the number of odd cows plus 1. Okay, now we can put this in code. So yeah, here we go. So the first thing, let's write our imports. And make our scanner. Okay, and close it too. Okay, the next thing we have to do is read in our input. So what we have to read in is the number of cows we have, and that's n. So I'll do int n is equal to in.next int. Okay, after that, we're going to read in all of our cow IDs. And we don't have to read them in an array right now because it doesn't really matter what specific values we have. All we really care about is the number of even cows and the number of odd cows, right? So I'll make 2 variables called even and odd, or even and odds. So in odds is equal to 0, and in evens is equal to 0. And then as I read in my cows, I'll automatically update odds and evens and to tell me how many odds and even cows I have. So while I read them in, I'll do that. I'll create a variable next, which stores the next cow. And I'll also store it mod2. So that'll tell me odd or even. If next, which is the cow mod2, if next is equal to 1, that means we have an odd cow. So I'll increase odds. And if next was 0, that means we have another even cow. So I'll do evens plus plus. Now I have the number of odds and even cows I have. So now I can do my greedy strategy. So in order to do that, first of all, let me check if I have more evens than odds. So if I have more evens, so if evens is greater than odds, then, if evens is greater than or equal to odds. The thing is, if evens is equal to odds, I guess I'll just make it separate cases. If evens is greater than odds, then as I said before, my answer is going to be 2 times odd plus 1. So I'll make an answer variable too. And I'll set it equal to 0 at first. So I'll say answer is equal to 2 times odds plus 1. And then we're done. But let's say evens is equal to odds. So remember that this plus 1 came from the extra group we could make, the extra even group we could make if our evens was greater than odds. But if we have evens is equal to odds, we can make the same number of odd and evens groups. So our answer will just be 2 times odds then, or 2 times evens, since they're both equal. Okay, now we have to deal with the case if there's more odd cows than even cows. And that's the two cases that we were dealing with in our samples. So the first thing that we did was we made all the even cows into their own even group at first. So we started our answer off at 2 times evens. because in the second example, we just put this even cow in its own group, and then the next group was just an odd cow. So that already made two groups. Okay, then we have to worry about all the additional extra odd cows that we have. So I'll make a variable to store that called extra cows, extra odds. And that's going to be odds minus evens, the extra odd cows that we have. So using those extra odd cows, we're going to have to make groups that have even cows and odd cows. So for each even group that I have to make with those extra odd cows, I'm going to have to use 2 of those extra odd cows. And for each odd group that I have to make, I'm going to use 1 of those odd cows. So let's just think about how that works as well. So if I have if I have an even, let's say that these were the extra odd cows that I have, right? I got rid of the odd and even that I already used for my first 2 pairs. And these are the extra odd cows that I have. So what I can do is I first have to create an even pair, right? Then I have an odd group. Let's call this thing a pair. So the number of pairs that I can make is obviously the number of extra odd cows that I have divided by 3, because I use 2 to make an even and 1 to make an odd. So the number of pairs that I can make is equal to extra odds divided by 3. And this does floor division already, so I don't have to worry about overflow. But now let's actually consider our overflow. So in this case, we had 2 extra cows. So that would make an extra even group. So if my remainder after dividing by 3 was 2, then I can just put those 2 cows to making another even group. So if extra odds divided by 3, or mod 3 is equal to 2, then I can make another even group. So I can actually update my answer right here. So I'll add 2 times the number of pairs I have, because for each pair I have 2 groups. So if I have extra odds mod 3 is equal to 2, I can make another even group, so I can increase my answer. But if the extra cows that I have after I pair up all these even and odd groups, if I only had 1 extra odd cow, then I can't make an even group anymore. And I can't make an odd group either. So what am I going to do with this extra 1 cow? I'll have to combine it with one of the other odd groups that I have. And if I do that, I get an even group. If I get an even group, then it's not going to keep up the pattern of going even and odd groups. So I'm going to have to combine this even group with another even group, and that creates this big even group. So the thing is, we started off with 2 pairs, or no, not 2 pairs, 2 groups. And then after I added my extra odd cow, it became 1 group. So in reality, all that happened to my answer was it decreased by 1. So if the extra odds divided by, or mod 3 is equal to 1, I'm going to decrease my answer. All right, so since it's a greedy strategy, I already built up to my answer and I don't have to do anything else to it. So I can just print this out. And now we can check if this works. So in the first test case, our answer should be 3. And in the second test case, our answer should be 5. There we go. So this is a correct greedy strategy for that problem. Okay, so does anyone have any questions about that problem or anything about greedy algorithms in general? Okay, so it seems that you guys are getting it. So what we'll do is we'll actually go on to more problems. So these were more, so this is another explanation of even more odd photos. And so here are some more greedy problems. And I didn't plan to go over them, but since we've already finished the first 2, let's do that. So the first problem is out of place. And I'll leave that in the chat. Okay, so what happens is Farmer John wants to, again, take a photograph of his entire herd of cows, and he lines them up in sorted order, from shortest to tallest. But what happens is Bessie, she steps out of the line and reinserts herself at a random location. And he wants to swap pairs of cows so that the entire herd is ordered again. And he wants to find the minimum number of swaps he has to do in order to achieve his goal. All right, so there's like a key thing in greedy algorithms we saw. So in all the problems that we just did, we were trying to minimize or maximize something. So yeah, if we want to count something or minimize or maximize something, that's a good hint that your solution to this problem could be a greedy algorithm. Okay, so let's take a look at this. So the first input that we get is we have the number of cows, which is 6, and we have the height of the cows in order. So this is the original lineup, and I'll copy paste that so we can talk about it. Okay, so this was the original lineup. And remember that when Farmer John started out, it was already sorted. So it should have been like if we sorted this array, this is what it should look like. It should be 2, 3, 4, 7, 7, 9. But clearly, the one that's out of place is 3. So that must be Bessie. And she has to go in this spot. So what we can look at is what is the fastest way we can swap cows in order to get to this spot. So in order to move a cow from the end all the way to this second position, well, we could first start off by swapping this 9 and 3. If we do that, we get 2, 4, and 7, 7, 3, 9. So now we move this 3 over here. And we can do the same thing again to swap this 7 and this 3. So we would have 2, 4, 7, 3, 7, 9. And we would do, or there should be 3 actually. Then we do the same thing again. We swap the 7 and 3. We do 2, 4, 3, 7, 7, 9. And finally, we swap the 4 and 3 to get the entire array in order. And we get 2, 3, 4, 7, 7, 9. So yeah, you can see that we had to make what? 4 swaps, right? We had one swap to go here, one swap to go here, one swap to go here, and one swap to go here. So if our cow started, if Bessie started 4 points away or 4 places from where she was supposed to be, it took 4 swaps to get back to the same spot. And is there any way to do this better? Well, no, right? Because if we tried swapping directly, if we tried swapping this 4 and this 3, we would end up with 2, 3, 7, 7, 9, 4, which is still not okay. And if we tried swapping anywhere else, we would still have to fix the disorder that we create in the way to do that. So this is really the best way to do it. In order to get back to our sorted position, we're going to have to go all the way from where Bessie was and swap the cows in order so that Bessie goes to the right position. So how can we do this? What we can do is we can find out the distance that Bessie is away from her goal spot or where she's supposed to be. And we can find that location by first swapping the array, or not, first sorting the array. That's what I meant. So we can sort the array and find out that Bessie is actually supposed to go over here, right? Okay. And instead of just looking at if Bessie is in the right spot, what we can do is we can find out how many elements are actually in the incorrect spot, because all the elements in between Bessie and her correct spot are going to be out of order. They're all shifted by 1 in the wrong direction. So if we sorted this, we have 2, 3, 4, 7, 7, 9, right? And we can see that the number of spots that are mismatched are 1, 2, or no, 1, 2, and no, it should just be 1, 2, and 3. But you see that the 7 actually aligns by itself, or 1, 2, 3, 4. Sorry. So we would actually have to make a lot of swaps, make 4 swaps. But okay, so here's the problem with this. You see that since these two are already the same, 7 and 7, we would not count that as being in an incorrect spot, and we wouldn't have to swap those. But we actually have to do swap them. So what we can do is we can find the first spot that is mismatched and the last spot that is mismatched, and then we can find the difference between those. And then we can find our answer. Okay, so now let's try doing that actually in code. And this one was called out of place. Where'd it go? Here it is. Yeah. Okay. So the first thing, as usual, we're gonna make our scanner. And then we're gonna make our print writer. And then close our print writer. Okay, then we can read in our n. And we can read in the order of the cows. So we'll just make one array for that. Okay, so that was our original array. But we also want to find our sorted array, and then we can use that to find which spots are mismatched. So we can make a new array, and I'll call it sorted. It's still going to be a size n. And what I can do is I can copy the elements from the original array to sorted. And to do that, I'll do sorted of x is equal to array r of x. Okay, now I can use the arrays.sort method on sorted. And now the array will actually be sorted. Okay, the next thing I can do is I can find the first and the last spots that are mismatched, because those are the two spots between which Bessie has to be swapped to. And that'll tell us our answer in the end. So I'll say int first. I'll call it -1 so far. And same thing for last. So I'll say if there's a mismatch, then I'm actually going to worry about the position. So if sorted of x is not equal to array of x, then how would I say that it's the first position? It's like the first position that's mismatched. Well, I started off first at -1, right? Which is not an index in an array. So that already tells me that if my first is -1, I haven't updated my first yet. So there hasn't been a mismatch yet. So the first time I have a mismatch, I can just check if first is equal to -1, then I can set first to be x, because that's the first index that's mismatched. Otherwise, I'm not going to change it. Okay, but now how do I tell if my last index is, or which one is the last mismatched index? Well, it doesn't really matter how I can tell, because the last time that I'm going to have a mismatched index, that will be my last like the value of my last variable. So each time that I find another mismatched number, I can just set last to that number. And this way, once I get to the last index that actually mismatched, my last variable will contain that last value. Okay, and then as we said before, the answer to this is actually last minus first, because it's the number of, it's like the distance between the two places where Bessie is supposed to be and where Bessie actually is right now. Okay, and then this should work. So let's try it out. Oops. So it says 4 right now, and let's see why. Okay, so here's another thing. The other thing we overlooked was that if we had two numbers that were the same, then instead of swapping them, like swapping them one by one, so instead of doing like, if we swapped 9 and 3 already, so we had 2, 7, 7, 2, 4, 7, 7, 3, 9, and then instead of swapping this first 7 and the 3, we can just swap the second 7 and the 3. So 2, 4, we can do 7, we can do 3, 7, 7, 9. And in this way, we can, by swapping these two, it's equivalent of swapping the first two and then swapping the last two. So we can keep track of this using another variable, which is like the number of repeats. So from first to last, let's say int num repeats. So we can just iterate over first to last, because that's the range we're looking at. That's the range we're going to swap over. So we'll start from x equals first and go to x equals last. I'll say if yeah, if like I want to check for repeats, right? So instead of just doing an if statement, I can use a while loop. So I'll say while array of x, so sorted or not sorted, array of x is equal to array of x plus 1, then I can continue, so x plus plus. And also I have to check if I'm going out of bounds again, so I'll do if while x is less than n, and array of x is equal to array of x plus 1. And then, if I have this actually, I still need an if statement here. Okay, and then now I can update num repeats while I do this. So I can do x plus plus and num repeats plus plus. Okay. Also, one thing to note is that num repeats should be the number of repeats minus 1, because in the end, I'm going to subtract num repeats from my answer. So right here, we had 2 repeats, but I'll actually subtract 1 from this and make it 1 because that's how much I can skip over. I can't skip over both of them. I can only skip over 1. Because if I skipped over both, I would swap this 3 and the 4, and then we would have 2, 3, 7, 7, 4, 9, which is still not in order. So I can do while x plus plus, and then at the end, I'll just do num repeats minus minus. No, that should be here. Okay, then I can print out last minus first minus num repeats. Uh-oh, why did we get an index out of bounds error? Oh, x is less than n minus 1. If x is just less than n, I'm just checking whether the index is out of bounds or in bounds in the array, not if x plus 1. Huh, that's weird. Why is it? So there's a problem why it's still showing 4. Let's try to figure this out. So my first index right here was 4, and my last index right here was 3. So the difference between is 4, because that's the difference in the indices. And then the number of repeats I had was the number of repeated elements minus 1. So that should be 1. So when you're initially doing this, you're also going to have num repeats equals or num repeats plus plus. Because at this point, num repeats is going to be 0. And then once I increase it one more time, num repeats is going to be 1. So basically what I'm saying is that when I'm going from first to last, I'm counting num repeats. So if this thing is repeated, I'm going to have num repeats is equal to 1. And then once I go to my next element in the array, then num repeats is going to be 2. So that must be the problem here. Let's try that out. Okay, now it's saying 3. So that must be right. And let's submit this to make sure it is right. Give me 1 second. Okay. So this, when you're submitting old problems for practice, you've also got to use file input and output. So yeah, that's what I'm gonna do here. Okay, so now let me try submitting this to make sure this is right. Let's see. There we go. All right. So another thing is that I did not include IO exception here. Throws IO exception. And I'll tell you guys why this is a problem. I didn't do throws. So throws IO exception. Let's try one more time. Okay, so now it seems to be working. Okay, so once again, when you're submitting solutions for USACO, if you have standard input, use scanner with system.in and print writer with system.out. But if you're submitting with a file, you have to use scanner in is equal to new scanner, and then you have to use the syntax new file, and then in parentheses, the file name dot in. And for print writer, you have to do print writer out is equal to new print writer. New print writer, and then the file name dot out. Okay, and then when you're using print writer, when you're using print writer for file output only, you have to use throws IO exception. You can also include it if you're doing standard input, but you must include it for file input and output as well. Okay. So yeah, so those are all for the greedy algorithms class for today. And there are two more problems that I recommend you do for greedy algorithms practice. They include photo shoot and race for bronze. And that's also the end of this USACO Bronze class, the 4-day class. Okay, so I just want to go for Bronze for a little bit. So most of Bronze is actually going to be simulation and brute force. So make sure to get a lot of practice for that because that will take some practice too. And there are some other topics too, including greedy algorithms, sorting, and grid problems. There's also a few graph problems. And while we didn't have enough time to go through that in all the classes this week or these 4 days, you can learn those and other topics in the USACO guide. So make sure to practice doing a lot of problems so you can prepare yourself for the contest. Other than that, thank you for attending this class. So at the end of this class, actually, I want you guys to take a minute or two to fill out a student survey, and you can find that on the Kid Teach Kid website. You can hover over this 2022 Meta Summer Camp and click on student survey. So I can also send the link. Okay. There you go. Now it's in, now it's in the chat. So you guys, please fill out that survey. Take 1 or 2 minutes right now and do it. Other than that, thank you for attending the class, and I hope you got something out of it, and hope you're inspired to do more USACO and learn more USACO. And remember to use the usaco.guide. It has a lot of resources, and it has explanations and solutions for problems. for each topic in bronze, silver, gold, and platinum.